Hey everyone, welcome back to part 4 of ECON 312. This is just the R supplement for monetary economics at Louisiana Tech. So we left off with video 3 with plotting the growth rate of M1, and the only thing I've done to this file so far is just to save the document. So if you, at some point you're going to want to have typed enough in your script file that you're going to want to save it so that you can come back to it and re-execute this code again. So you can either hit Command S or Control S, or you can actually just go up and hit click on Save As or something like that. And when that'll happen, it'll bring up a dialog box just like normal. If I'm going to go over here to my Files tab, I went ahead and just saved this in my root directory just to show you that, yeah, you can do that, but you can also navigate to anywhere else you want. If you're running out of RStudio Cloud, you can either create a separate folder for your code within that project, or you can leave it directly in the root directory too. There's nothing wrong with that within RStudio Cloud. You'll notice when you do that, this is where some slight differences between RStudio Cloud and just the base RStudio app that you might download for a native application. You'll see some slightly different options here along this main menu of the Files tab. You can see an upload and a download, because you might want to upload or download your code or any other objects that you might have saved. Maybe you saved, I don't know, an image file as a JPEG or a PDF. But other than that, this largely operates exactly the same. So we've saved this file, and now we're ready to move on to M2. So great. So I'm going to go ahead and build this this graph just the same way that we built M1. I am going to take this and I'm going to copy it. And largely the reason why I want to copy it is because it's just the most efficient. There's not much that we're changing as we move throughout these monetary aggregates. However, I am going to change something to kind of add to this plot, if you will. The first thing, before we add to it, I'm going to change, make sure we're not plotting M1 anymore, and we're going to be plotting M2. And I'm also going to change the title, because the last thing I want to do is to think that I'm looking at something for M1, but really it's M2. So we'll change both the title as well as the actual Y variable that we're plotting along this line chart. Now, after a geom line, I'm going to add something else on top of this. Everything within ggplot is kind of like a layered thing. So as you add additional components, you're layering on additional details over top of things. So we're going to add another line to this, but it's going to be a slightly different line. It's still going to have that geom prefix for geometric, but in this case, I'm going to want what's referred to as an H line. And the H line stands for horizontal line. So it's just going to be a straight horizontal line. And the thing that I want to put here, we have to specify then a y-intercept. So we have this y-intercept argument here. And I'm going to bring in another function. I'm going to bring in the mean, which resides in base plot, and is basically just an average. And so great, so we have the mean here, and I'm going to define the mean to be M2. However, because the mean function resides in base R and it doesn't behave quite like ggplot, I could just refer to M2 because it already knows that everything within the data frame is for the money data object. But the mean function doesn't know that, and so we're going to have to specify, in this case we want the money object, and then we're going to put a $sign here. And not because it represents money. That's kind of funny when you think about it. But instead, the $sign is the delimiter within R, meaning kind of like an index. So it's going to allow us to pull a specific column from the money data frame. And in this case, we want to arrow down to M2. So what we have here is basically a geometric horizontal line, where the y-intercept of this horizontal line, it doesn't have an x-intercept, only a y-intercept, and the y-intercept is going to be the mean, or the average value of the M2 vector inside of the whole money data frame. Now I'm going to arrow out of this first parenthesis, so be careful with that. And then I'm going to add a comma, and I want to define the color, because I think it would be better if we made this a separate color rather than just a black line, and we're going to make that red. That way it'll kind of stand out a little bit. And then at the end of this, we need to go ahead and be sure we add that plus sign. If you don't add that plus sign after the geom H line, then all of the labs, all of these different settings that we've set up for the labels of the plot, they're not going to run. It would stop right there. So we want to make sure we have that. And I think at this point, we're ready to hit execute on that. Yeah, there we go. That looks nice and pretty. It looks relatively similar to M1, although it has some other transient spikes happening in here. The volatility is somewhat reduced. It's not quite, the peaks aren't quite as tall, and the decreases, the drop offs, the spikes at the bottom aren't quite as deep either. So it's got overall reduced volatility than the growth rate of M1. Now, another thing that we can do here that is kind of helpful and neat is we can save individual plots, and I referenced it earlier, but we can actually save this object, if you will. Everything in R is an object-oriented programming language, and you heard me say that earlier on in video 1. But basically what we're going to do is we're going to save this plot by name, and then be able to call that name later on. Now, usually you get introduced to the way we kind of reference things here within R, as we would take a name on at the beginning of a line, and then we would arrow into that name, and then we'd have the rest of our code. And you'll see me do that, but in this case, it also runs the other way. So I'm going to put here a right arrow, and then I'm going to call this m2 underscore plot. So when I execute this, now it is saving all of this information into an object called m2 plot. And if you saw this move over here out of the corner of your eye, you'll see that we now have another named object in our global environment for m2 plot. If we wanted to see that, then we would actually have to type out, hey, I want m2 plot. So print m2 plot, and then it prints the actual plot. So that's very helpful to be able to name a specific plot as something else. We can either put that into a list of other things, or we can then save that by name if we wanted to export this into some other format. All right, be sure to hit save. So we save all of that. We're good to go. Now, I want, as my students, I want you to do this exact same exercise for MZM. So pause the video, and then I want you to go through this code, copy paste it, change M2 to MZM, and then examine all of the dynamics of MZM and make sure they line up with our slide. So I'll give you a moment in order to do that, and then you can come back. All right, so I'm assuming you've come back and you've actually done that. So if you haven't done that, then pause the video and, like I said, actually do what I told you to do. All right, so great. The next thing we're going to do is I want to pull up the final plot that we talked about within our slides over here. And we plotted all three of these growth rates of our monetary aggregates in one plot. Now I'm going to rearrange this data a little bit. So we're going to need another library here. When you downloaded Tidyverse, it not only downloaded a collection of certain packages, but then sometimes the individual functions in those packages rely on other functions that are in other packages. Those are called dependencies. And so it also downloaded the dependencies too. So you should have also a package called reshape2. I'm going to go back up here to the top because I always like to put all of my libraries that I need up at the very top of my document. This is largely because I'm rather particular. I will say I'm particular about how my code looks, and so I just like it to be nice and neat. So we're going to type in reshape2, and that should have downloaded. I forget which specific library that it's needed for. I don't think it's dplyr. Probably. Well, I don't know. I don't remember. Anyway, I just know that it's needed for one of the libraries within the Tidyverse, and so I'm going to execute that line. Be sure after you type in library reshape2 that you actually execute this line. Otherwise, the next line will not run. It'll say we don't know where this function is that you're calling it from. So now I had already loaded it in my own. In this particular project, when you actually execute library reshape2 for the first time, you should see a couple of other different colored comments that pop up here. As long as it's not a warning or an error message, then there shouldn't be any issues. If you do get a warning or an error message, then what do? Well, you copy paste it and you put it into our Slack channel and you message it to me, and I'll tell you what's wrong with it. All right, so over here now we're going to create a separate data object. And again, we're going to use that arrowing component here, but I'm actually going to do it now in a different way. So we're going to define an object called plot_df. So basically, I'm going to create another data frame specifically for a plot. This is just kind of a generic throwaway name that I tend to put whenever I'm rearranging data and want it to be another separate data structure within the global environment. So we'll use what's referred to as the melt function. Now, if you're typing this in and melt doesn't auto show up in here inside of RStudio or RStudio Cloud, you haven't loaded the library for reshape, otherwise it wouldn't show up here. So just FYI. So great. So you should see melt, and the first thing we need to do is we need to define the data structure for this. So we want the money object, and the melt function kind of reshapes certain data. It does something specifically. It restacks the data according to an ID variable, and the ID variable in this case is going to be our date column. So it seems relatively benign, but I'll show you what this does and how now the new plot df function is going to be different from the money data frame. So notice here we have a left arrow. You tend to use arrows when defining things. It operates kind of like an equal sign. However, like within ggplot, you wouldn't want to use an arrow in here. Certain functions don't allow that functionality. You could replace this with an equal sign. In most instances, you can within R, but usually you can't replace the equal sign in most instances with an arrow. So yeah, it's one of those weird quirks within the R programming language. So I'm going to execute that line. Notice we didn't get any error message, and notice over here within our global environment we have plot df. So we're going to view this, and I'll just put this down here because I don't really want this to be within my code. So we want to view plot df. So here's what the melt function specifically does. It stacks the data. So before, within our money data frame, notice we had one column for date, one column for M1, one for M2, one for MZM. Now with the plot df data frame, we have our date column. We have a variable that repeats itself over and over and over for M1, so each value corresponds to M1 for that specific date, and then we have the corresponding value. So we can scroll down all the way to 2020. Well, I'll give it a second. Come on now. You can do it, computer. There we go. And then all of a sudden M1 will switch over to M2, and M2 will be stacked right underneath M1. So we reshaped our data for us as if we're stacking the actual true values of M1, M2, and MZM, and then we have a separate column for the specific label of what each of these variables actually is. And the date column is stacked 3 times on top of itself. That different formatting or structuring of data, that's what was referred to as a tidy structure of data. And so thus the name of the vernacular tidyverse. It's just a different way of dealing with data that previously wasn't a part of the original paradigm of R programming. So we're going to use this plot underscore df or plot df data frame in order to do our last plot. So we will start with ggplot, and then we're actually going to build this one from scratch. So we'll do plot df. Great. And I'm not going to put the aesthetics in here. Instead, I want to put the aesthetics commands within the geom line function. And I do this so for a couple of reasons, but primarily to show you that aesthetics command, it can go either in the global ggplot options, but it can also go into the individual lines that you're after. So we're going to use geom line, and then we'll define the aesthetics date. Y. In this case, our Y value is going to need to be our value column. So we have to call it by the name here. So what we're actually plotting for our Y variable is going to be the value. So we'll be sure to change that. And then we're going to define the color. And we're going to set that equal to variable. And the reason why we're setting that equal to variable is because if we go back over to plot df, we see that middle column has the name variable here, and that determines whether it's M1, M2, or MZM. Great. Add a plus sign, enter, and keep on going. So we're still going to have labs. Let me pull the labs from the previous command, because why not? So X we're still going to leave empty, Y is still going to be percent, title, in this case I'm going to say title is monetary aggregates. And then let's kind of make this a little bit fancier. Let's add a subtitle, and then we'll say growth rate. Excellent. Now the last thing we're going to do is I want to change the scale here, or the coloring scale. So this is something that you don't necessarily have to do. I'm very particular about the coloring on my graphs. I don't like some of the base coloring schemes that is available within ggplot, so we may as well get familiar with changing those. So I'm going to select scale color underscore manual. Great. And then we'll define the values. And so the values column is going to have to be a collection or a column vector of 3 different values, and this may take a little bit of time to type out, but hey, it'll be nice, so it'll be worth it. So we'll do some single quotes here, and we'll do $0.45A8D for color 1, and these are what are referred to as hexadecimal codes. They're 6-digit codes that kind of define the range of possible colors. So F03B20 0, pardon me, not O. And then for our final one, we'll do $FECC5C. Great. Excellent. So at this point, we're kind of ready to go. We've got everything that we want here. We've defined our plot. DF is our data object. We still have date along the horizontal axis. For the y variable, we're plotting that value, which has 3 different variables, and then we're defining the colors along the differences of those 3 different variables. We have all of our labels in place. Everything looks good. Assuming we've typed in all of the manual hexadecimal codes correctly, we should be good to go. Ooh, and there we are. We have a nice pretty plot. Let me make this bigger. Excellent. And so this should be exactly what we produced or what you guys saw in the slides for this lecture. So we have all 3 growth rates for each of the 3 monetary aggregates that we examined, M1, M2, and MZM. And again, you'll notice that the growth rate of M1 has a much higher volatility than does M2 and MZM. MZM is still somewhat more muted, more often than not, than M2, but that isn't always the case. Now, the interesting part about this is we cannot necessarily say that this is always the case. This has been the case for the past 20 years. If we go back further in time, then depending upon your time window, you can't necessarily say that M1 is always more volatile than M2, because we've definitely seen in history where that's not been the case. So we do have to be relatively careful to not draw that such a broad sweeping conclusion from this limited window of data. But now we've produced exactly what we talked about within our slides, and yeah, we're good to go. Be sure to save this document. I'm going to save it here. If you want to save those plots, you certainly can, although you certainly don't have to. You now have the code in order to be able to reproduce those plots whenever you want. So if you have any questions, feel free to reach out to me, leave a comment down below, or reach out to me on the Slack channel if you're one of my students. Thank you very much for watching.